Hi class, it's Mrs. Cornett again, and this video is going to be all about finding percentiles from a set of data and then identifying which data is in a specific percentile. This is going to be the same examples that I may have used in class, but I just wanted to make this recording for you in case what I covered in class didn't quite settle in with you. So if you want to pause the screen and copy this into your notes, you can. Percentile is a ranking. It's easy if I just jump to this example down here. If Joey scored in the 70th percentile, that means 70% of the students scored less than him. So I drew this picture in class. Here is Joey. Here he is at the 70th percentile. That does not mean that he scored a 70 on his test. He just scored greater than 70% of the students, but 30% of the students scored higher than him. And so Joey, and possibly some other kids, if we're considering the entire state of Tennessee, fell in the 70th percentile. Okay. This slide is steps that I wrote out for you to convert a raw data to a percentile rank. We are going to be using this equation listed out to identify the percentage of that data, and that finding the percentage, the number of values less than y over the total times 100, that's just converting a ratio to a percent, but that is going to help us to identify the percentile rank. Percentiles are in whole numbers, and you need to just use regular rounding rules. If you want to copy this slide into your notes, go ahead and hit pause to copy them down. Okay, so let's take a look at these three examples. Notice that I have that formula up top. In each of these questions, one value from the list of data below has been given. In the formula, we are calling these values the y variable. So question A says, what is the percentile ranking of the value 61? So the ratio that I'm going to set up is I'm going to count the number of values less than 61. Well, that's easy. There's only one less than. Now I need to identify the total number of data points, 15 data points. And so right now we're going to find, okay, 1 out of 15, and we're going to multiply that by 100, and that gives the decimal 6.67, but percentile ranks are not decimals. If you use regular rounding rules, this would round to the 7th percentile. Question B, what is the percentile ranking of the value 84? Notice that there's two 84s. I want you to count the number of values less than y and let y be the first 84 on that list. So this will be 1, 2, 3, 4, 5, 6, 7. So 7 values out of 15 are smaller than 84, so we're going to convert that ratio to a percent. And it converts to the percent 46, and we'll go ahead and round it to 6.67 again. Percentiles are only given in whole numbers, and so we can say the value 84 falls in the 47th percentile. Okay, one more with this set of data. We are now going to look at the score of 92, so that will be our y for this equation. For this question, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values smaller than 92, so 10 out of the 15 data points is smaller. Convert that to a decimal, and the decimal is 66.67. Starting to see a little pattern here with our 0.67s, and we'll round that to the 67th percentile. This time the data is listed in this grid, this table. It still is in numerical order. It just starts right here at A1 and it goes down, and then it goes to the top of the next column and goes down again. So now we know from doing that previous problem that we need to definitely know the total number of values. We can either count, 4 times 5, do a multiplication problem, or up here in the original question it says 20. So we know n is 20, which is the total value points. Here are our questions. Find the percentile corresponding to 3.6. So I'm going to start at the very top and identify 3.6 is right here, and that will be our variable y. Now I'm going to count the values less than y. 1, 2, 3, 4, 5, 6, 7. So for question 1, it's not a ton of room, but it would be 7 out of 20, and I'm going to multiply that by 100. I'm converting it. What percent of the data is less than y? 7 times 100 is 35. So since we know 35% of the data is less than this value, we can also say that this value 3.6 is the 35th percentile. Question 2, it says find the percentile corresponding to 3.4. Notice on this one there's two 3.4s. We are always going to start with the first one that shows up on the data. There are 4 out of the 20 values less than 3.4, and so let's go ahead and convert that information to a percent. 20% of the data is less than 3.4. So that means, by definition, because 20% is less, 3.4 is the 20th percentile. Okay, next we're going to look at 5.6. There's two 5.6. We're going to take the first one. There is 5, 10, 11, 12, 13 out of 20 less than. We'll multiply that by 100 to find the percent less than 5.6, and that is 65% of the data is smaller than 5.6, and so that puts 5.6 at the 65th percentile. One more, 6.5, there is 17 out of 20 values less than 6.5. We'll convert that ratio to a percent, which would be 85%. Because 85% of the values less than 6.5, because 85% of the data is less than 6.5, that specific data point sits in the 85th percentile. Okay, now we are going to go just the opposite. These next few questions, you're going to be given a specific percentile rank and a list of data points. And you need to identify which one of those data points corresponds to that given percentile. But I want to point out a few things just to make sure we're clear. This first definition of the variable I, it says the numbered position of x. Let's just say this data is 5, 8, 9, 10, 15. We have five data points. So when I'm talking about I'm talking about the numbered position of x, which is a single data point. So x is 5, x is 8, 9, 10, and 15. But the 5 is in position 1. The 8 is the second in line, so it's in position 2. 9 is 3, 10 is 4, 15 is 5. In class, you may have heard me also refer to this idea as chairs in band class. Do you remember that, the student who played the best clarinet always got first chair, and then it would go second chair, and then third chair, fourth chair, fifth chair. Those were the position that they would sit in band class and at a band concert. And so the same is true with these numbers. Once you put these numbers in numerical order, 5 is in that first chair. So the numbered position for the data point 5 would be I equals 1. The position of the data point 8 is I equals 2. So just those position numbers, that's what I'm calling I in our formula. If you need to pause the screen to copy this down, please do so. Okay, and then once you have identified I, you have two options, and you definitely need to write these two down in your notes. So again, if you need to pause the screen. Okay, so let's use all that information and answer a few questions. We have our data set down here below. Question A says, which value is at the 40th percentile? Well, the first thing we should do is go ahead and just count the total number of values. And so to find the 40th percentile, it would be easier to just find what is 40% of the data, and then the value just above 40% of the data we could mark as the 40th percentile. So the formula says I equals 40 over 100 times 10. That is basically just saying 40% of 10. Okay, so we're going to type that into the calculator. You could also just type in 0.4 instead of 40 over 100. Either way is correct. But this is going to give us the number 4. Now guys, that is not the answer. That is I, which is the position of the data. So let's go down here and look at our data. 2 is in position 1, I equals 1, we could say. 5 is 2, 3 is in position, 10 is in position 3, 11 is in position 4. So what we just found out is that these first 4 values make up 40% of the data. So we cannot say that 11 is in the 40th percentile because that would not be true. 11 is in the lower section, is under the 40th percentile because it's part of the 40% of the data. And so on the previous screen, what you just wrote down is that when I is a whole number, we are going to take the I4 and find the average with the very next data point, which in your notes, you said I plus 1, which would just mean the next data point. And so we're going to average those two together. 11 plus 14, divide that by 2, gives us the score of 12.5. Now that is not one of our data points, but it's right here, and that's the 40th percentile. It means 40% scored less than 12.5 and 60% scored greater than 12.5. Okay, let's do that again. Which value is at the 15th percentile? In order to identify that, we need to know what 15% of the data is. And so we'll run it through this equation. 0.15 times 10 is the decimal 1.5. When I is a decimal, we're always going to push it up to the next whole number. We have already passed rank 1, okay, band chair 1, because this is a 1.5. And so somewhere right in here is 15% of the data. And so we are going to round it up to a 2. And so that means the number that's sitting in position 2 is considered the 15th percentile. That would be the number 5. And so the answer to this question is 5. We found the position number, which is 2, but then you have to go back and match which number is sitting in position 2, or which number is sitting in the second chair, if we go back to that band analogy. Okay, one more on this screen. We're going to find out what 61% of the data is. 0.61 times 10 is the decimal 6.1. We have passed rank 6, so we know these 6 and just 0.1 past that 15 makes up 61%. But there's not a number right there at 6.1 that's on our data. And so the next number on our data, so that we can identify as the 61st percentile, is right here. It's 16. It's in position 7. And so that's why the instructions say don't use the rounding rules, but just every decimal rounds up to the next position, which in this case would be position 7, and 16 is sitting in position 7. Okay, a lot of times you'll see on WebAssign or a class exam this idea called a percentile table, and it will just already have the percentiles listed out, and then you just need to identify each of these percentiles. And so we're going to run through the same thing. Okay, so we're going to use that same formula and work through this again. The first thing we need to identify is how many total data points. There is 15 in this example. And so to find the 25th percentile, we need to first identify 25% of the data. That would be 25 over 100 times 15. Remember, this is just to identify I, which is the position, gives us the decimal 3.75. Well, if you look at our data, we have position 1, we have position 2, position 3, position 4, position 5, and so on. There is not a position 3.75. We're not going to decrease the position back to 3 because it's greater than the third position. It's greater than 16. So we're going to go ahead and round it to the next number on our list. And so the 25th percentile is 22. The 50th percentile, we're going to find what 50% of the data will be, and that gives us a decimal of 7.5. Okay, again, if you go back and look at our positions, 30 is in position 6, 31 is in position 7, 35 is position 8, and so on. 7.5 is not a position. You're going to round all the decimals up to the next position, and that would be 8, and the value sitting in the 8th position is 35. So that is our 50th percentile. Okay, last question. We're going to find the position of the 75th percentile. So that would be 75 over 100 times 15, and that gives us a decimal position of 11.25. 57 is in position 10. 60 is in position 11, 61 is in position 12, and so you just need to round it all the way up to the next whole number, the next position, which would be position 12, and that's the value 61. Okay, let's take a look at this question. This was copied from your WebAssign homework. It says, if a 20 percentile wage is $23,000, then 20% of the workers in that occupation earn less than $23,000, and 80% of the workers in that occupation earn more. Okay, so here is our percentile table up here. We know the 10th, 25th, 50th, 75th, and 90th percentile of elementary teachers. Question 1, what is the 75th percentile wage? If we go up to the chart, the 75th percentile wage is $63,600. Next question, what percentage of elementary teachers earn $40,850 or more? There is that value right here. That amount of money has been tagged as the 25th percentile mark. So we know that 25% of elementary teachers make less than that amount, and 75% earn more than that amount. So our answer is 75%. Question 3, what percentage of elementary teachers earn less than $50,510? Okay, that amount of money has been tagged as the 50th percentile. And so by definition, we know 50% earns less than that, 50% earns greater than that, and so the percentage that earns less is 50%. The final question, what is the range of wages among elementary teachers? Range goes back to an earlier lesson. That is just the greatest amount minus the smallest amount given. And so for this problem, the only information we have is we're going to take the 90th percentile, which is 78,720, and subtract the smallest given wage, which is 33,830, to get a range, it's a big difference in pay, of $44,890. Okay, so that is all for this video. I hope this will help you as you are working through your problems that involve percentiles. Please reach out to me if you have any questions, and I look forward to seeing you back in class.